Hello everyone, and welcome to a quick recap of a free response that we were working on. So we had a 30 microfarad capacitor, and it was connected like this with a 4 ohm, 4 ohm, and then an 8 ohm resistor. And there was some other stuff over here, but a junction failed, and so we were left with just this circuit. And it asked us how much energy is going to be dissipated across this 8 ohm resistor. Well, in order to do that, we're going to start with only the potential energy stored on our capacitor. And we know that that is equal to 1/2 QV or 1/2 CV squared. And we calculated that the voltage across this capacitor, I'll call it VC, it was 10 volts. We calculated that previously whenever it was hooked back up to the battery. So we want to know the energy dissipated. Well, we know that power is PIV, and power is work over time. Power isn't energy. Power is energy over time. And so if I want the energy dissipated, well, that would be how much power a resistor has divided by the time. But a certain amount of time is going to pass before this thing discharges. How much time? Well, we don't know, but it's the same amount of time for each one. So with that, we can figure out, okay, we start with a certain amount of potential energy. Each one is going to get a ratio of that energy, and that ratio is going to depend on its current and its voltage. So in order to do this, I'm going to redraw this circuit. And I'm going to draw it in such a way that we can see how everything is connected. So here's my capacitor, and the wire coming off of it, if you look, the wire coming off splits in a junction. So I'm going to draw it splitting in a junction. And off of one junction, it leads me to the 8 ohm resistor and then the 4 ohm resistor. So that's what I'm going to do. Off of this top junction here, I'm going to get the 8 ohm resistor and get the 4 ohm resistor. So there's 8 ohm and there's 4 ohm. Then, off of the other junction, I hit the 4 ohm resistor. So, I'll draw that. Then, those two junctions meet back up and then connect back to the battery. So, I'm going to draw them meeting back up and then connecting back to the battery or the capacitor. In this case, the capacitor is serving as the battery. And at the first instant, right when that junction splits, I start out with 10 volts. So I've got my 4 ohm resistor and then my two 8 ohm resistors. Well, seeing this now, we can see that, okay, my 8 ohm and my 4 ohm are in series with each other. Just like we thought, they should have the same current. But those two resistors are in parallel with that resistor. So let's figure out our equivalent resistance. If I combine those two resistors, well, these two are in series, so I get an equivalent resistance of 12. Then that 12 ohm resistor is in parallel with the 4 ohm resistor. So the equivalent resistance for the entire circuit would equal 1/4 plus 1/12. So doing that, I would get 1/3, reciprocate both sides, I get a total resistance for this entire circuit equal to 3 ohms. Knowing that, I can figure out how much current is being drawn directly out of my capacitor, right when the circuit is flipped, because I know the total resistance and I know the voltage. So V equals IR, my voltage is 10, my resistance is 3, so my current drawn right when the capacitor is connected is 10/3 of an amp. So that means that I have 10/3 of an amp flowing right out of the capacitor, and I've got 10/3 flowing back in. So knowing that, I could figure out how much current is flowing through each. And if we look at this, let's look at the loop rule. I make a loop right here, if this is 10, well, then the voltage across this has to be 10. And if I know the resistance and I know the voltage, I can solve for the current right here. And so if this is V and this is R, well, I in this resistor is just going to be 10 over 4, or 5/2 of an amp. And if I know that this is 5/2 of an amp, well, I've got 10/3 flowing in and I've got 5/2 flowing through that wire. Well, that means I've got to have 10/3 minus 5/2 flowing through that wire, which means I get a current up here equal to 5/6 of an amp. Well, now I know the current and I know the resistance. I can really dive into my 8 ohm resistor and I can solve for the voltage. And just like we thought, the voltage across that resistor is going to be 20/3. So here's how we figure out how much energy this is going to consume. It's a ratio of its current to the total current and its voltage to the total voltage. So with that, my 8 ohm resistor had a voltage of 20/3 and a current of 5/6. My voltage for the entire circuit was 10. And my current for the entire circuit was 10/3 of an amp. So to get its power consumption, it's going to be its current divided by the total current and its voltage divided by the total voltage. That gives us the ratio. So if I take 10/6 and 5/6 and I divide it by 10/3, well, I get 1/4. And then 20/3 is 2/3 of that current. So this is 1/4 of the current. This is 1/4 of the total, 2/3 of the total voltage. So its power consumption, that's how much energy it's going to consume relative to the total energy. So my current was 1/4. My voltage was 2/3. So whenever you're doing a problem like this, figure out what the ratio is of your resistor to the total, your voltage to the total, multiply the two together, and that will give you the percentage of its total energy consumption.